Good morning, good day, and good evening to all our attendees joining us for today's latest Data Science Central webinar. I'd like to start our event off today by thanking Trace3 for sponsoring today's event. Trace3 is a new partner and supporter of the Data Science Central community, and we're honored to have them sponsoring today's webinar. I would also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including MapR, Databricks, Splunk, Tableau, Teradata, and Pivotal, to name just a few. These past webinars and many others are available at datasciencecentral.com, and you can view them on demand. They do provide some very useful information. Today's webinar is entitled Hadoop Automation, Eliminate Data Bottlenecks. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be approximately 1 hour long. We have 3 panelists that I'll introduce to all of you in just a moment. We should have about 10 to 15 minutes for a Q&A following the presentation, and this event is being taped and will be made available later on this afternoon at datasciencecentral.com. I'd also like to encourage our attendees to provide questions throughout the presentation. We will be reviewing them and presenting them on your behalf during the Q&A portion of today's event. My name is Tim Madison. I'm one of the co-founders of Data Science Central, and I will be your host. I'm very pleased to introduce today's panelists, Nick Durkin of Trace3, Tim McIntyre of StackIQ, and Shawn McEwen of Cisco. Nick is an architect at Trace3. He possesses over 10 years of data center architect knowledge combined with a wealth of certified training. Nick also owns over 3 years of Hadoop and big data experience, architecting systems and building big data applications for not only the federal government, but also the world's largest financial institutions. Tim is a co-founder of StackIQ, which brings the cluster of computing sector's thriving open source community into the enterprise, which dramatically reduces the time and cost of setting up and managing clusters through intelligent multi-server software automation. Tim's previous work includes leading the development team of at the Digital Image Analysis Lab at Scripps Institute of Oceanography. He has a Bachelor's of Science in Computer Science from the University of California in San Diego. And Shawn is a technology solutions architect in Cisco's data center and virtualization, where he has a global role of designing UCS and Nexus-based customer solutions for big data deployments, running Hadoop, NoSQL databases, and similar massively parallel scale-out applications. Shawn joined Cisco from Oracle, where he was the IT director in their global IT service operations group. He has 18 years of IT industry experience, a Master's of Science in Astrophysics from Northwestern University, and a Bachelor's of Science in Physics from Georgetown University. Welcome to you all, and thanks for joining us this morning. Trace3 Big Data Intelligence Team has developed a program which incorporates the participation and partnership of StackIQ and Cisco to automate the deployment and management of Hadoop clusters and overcome cluster management challenges. In today's webinar, you will learn how the partnership of Trace3, Cisco, and StackIQ accelerate infrastructure deployment for faster, easy growth, deliver big data Hadoop infrastructure in small, efficient footprint, handle the most complex workloads with Hadoop clusters supported by hundreds of servers and petabytes of storage, quickly load terabytes of data into the system over a high bandwidth unified fabric, quickly gain customer insight and business intelligence to enable faster innovation, and finally to automate big data Hadoop process to deliver reliable, cost-effective decision science. So with that, Nick, I'm going to turn this over to you, and you can begin your presentation whenever you're ready to go.
Thank you, Tim, and truly thank you guys from Data Science Central. Today we're here really to talk about Hadoop automation, but I wanted to give you guys an idea of who Trace3 is and what we've done in the community and how we can help you. Trace3, 12 years ago, we started as a VAR. We provided anything you wanted in your data center, whether it was storage, networking. We moved on based on our customer wants and needs to really provide integration services. And so we built practices around our specific technology stacks that were most purchased and most used. And then we really wanted to make sure it was an engineering-centric organization. So very different than most of the VARs that you might work with. But we have, at current, as we move into innovation, we have almost a 6-to-1 engineering ratio, which is amazing to have 6 engineers for every salesperson. Beyond that, we've moved into things like education, providing education services, and not only your standard big box technologies, but your big data and cloud technologies, as well as even providing education services for some of the startups coming out of Silicon Valley. And that actually brings us to our VC briefing technologies. And what we've done is we've partnered with the largest venture capitalist firms in the country to provide benefit to all of our customers. In fact, DirecTV's CIO, Mike Benson, wrote in the Wall Street Journal about how Trace3 helped him by bringing all the new technologies from the VCs to be able to help him grow his company, truly innovate, to move forward above his competitors. Beyond that, we were Cisco's Innovation Partner of the Year last year, providing cloud and big data services that our customers really wanted and needed. And the reason we do this is because this is the landscape that stands before you, right? This is the problem that we all have. There are multiple different options, and multiples may be the wrong word. There's a massive amount of options that you can use to process your data. And they all have different abilities and different capabilities, but we truly want to make sure that they're viable corporations, that they're performant. And beyond that, they work with what you have in your tool sets inside your company. And because we all have every Thursday and Friday to just sit there and research these, I know we all have the time to go look at them. But what's beneficial is that Trace3 has an entire group around their organization that spends their time researching these. So we go and we work with the largest venture capitalist firms. We find not only the large companies that we all know, the Clouderas, the MapRs, the Hortonworks, the Oracles, but we move on and we even go further and we go into some stealth companies, and we can actually go and vet them and make sure that they're functional and allow them to provide value to your company. The only way we can do this is through a truly agnostic approach, right? If we were to come in with a single doc solution and say this is how you solve all your problems, like a lot of people do, that doesn't make it functional for your business. So by taking an agnostic approach and making sure that we come in with a massive quantity of vendors and be able to design our solutions around you, that's truly what our customers have wanted. And that's been successful amongst quite a few of our references. And I wanted to show you just a few of the household names so that you could have an understanding of the large enterprise that we're able to deploy these at, because we actually make big data work. We take and we diagnose that enterprise and make sure that anything that we provide will actually become a truly productionalized system that's supportable. And how we do this is very important. There's three ways that we do this. We take a holistic approach, which is extremely important. If we don't go and find and look at your tools, your application set, your people and their skill sets, and even their propensity to learn, we might then realize that they might not be able to handle these large, brand new big data technology, and we have to offset that with certain tools for different skill sets. Beyond that, we move into constant innovation. So with our VC briefing technologies, with our constant research and technology, we can't sit stagnant, because anything that we would provide, we need to guarantee that we future-proof your business. And beyond that, and what we're here to talk to you about today, is really operationalizing engineering tasks. No longer do we have time to sit here and just do these mundane tasks and have massive amounts of people. A lot of our companies that we're working at aren't at the scale of Yahoo or Google, so we don't have thousands of people on the floor to be ripping out servers and moving and dealing with these big data technologies. So how do we operationalize those? In reality, the two technologies that we provide to you today have been phenomenal foundations for all of our enterprise customers. They've provided extremely amazing solutions that have allowed them to be extremely productive. And with that, I introduce now Shawn McEwen from Cisco.
Great. Thank you very much, and I really appreciate the opportunity to come and speak with everyone today. That's a great introduction to what we're doing, and I'm going to start with a kind of a little bit of a I want to say deep dive into a couple of technology components that I'm going to build upon later in the deck. So bear with me here at the beginning. I'm going to give you a very, very brief overview of the Cisco Unified Computing System. This is our server and networking platform for the data center, so the space in which most Hadoop implementations run. And I want to just give you just a few concepts, a little introduction to what differentiates UCS, what makes it different from other computing platforms. And then we're going to build upon that in the second section and apply those principles to the big data arena. So with that, let me begin with just a sort of quick look at how servers, physical bare metal servers, are typically installed in the data center today and managed in the data center today. And the problem we find, and this is a problem I had back when I was at Oracle, when I was running IT for our global IT team back there, we had this issue with identity that was wedded to the physical servers. Regardless of your virtualization scheme, your cloud environment, whatever you may have, there is this still a significant level of identity and state that is wedded to the physical hardware. In this example I'm showing here, these are just a few of the kinds of parameters and componentry that you actually have to, as a sysadmin or what have you, deal with on every server. And we're talking about BIOS settings and firmware versions, and maybe if you're on a SAN, the worldwide port names of your host bus adapters, and so on and so forth, server UUIDs. There's a laundry list here, obviously. And all of those pieces have to be configured down one at a time at the individual server level, effectively. And if you change a server, if you replace it with a failed component and you bring in a new one, you have to redo all of this work because what you did was fixed and stuck in that piece of bare metal. And so what Cisco has done, which is very unique in the server industry, has gone and essentially found a way to abstract all of that identity from the physical componentry and pull it out and essentially store it in what we call a service profile. It's essentially an XML file with all of the various parameters, attributes, and settings. And we store that service profile for each server in our switching infrastructure in a database called UCS Manager. And that allows us then to essentially abstract and decouple identity from the physical bare metal. And with that, we have all sorts of abstraction capabilities at our disposal, which we'll talk about and we'll use in the subsequent slides. But you can imagine once you've abstracted, you now have the ability to create templates from which a group of servers can be built. You can create resource pools for IP addresses, MAC addresses, that sort of thing, and assign certain servers to a given resource pool so that you're guaranteed to get have a single server be assigned the proper resources that it needs for its ability to function. And then, of course, you can change all of that very, very easily, reboot the server and have it come back up and assume a new identity as needed. Another capability that comes out of this abstraction and another piece of the unified computing system that we're going to again discuss in the subsequent slides is the ability to essentially create a unified fabric, a single fabric that contains and enables all server traffic, whatever you might need for your needs. And so what we've done here is we've taken the physical adapter, the physical 10 gig Ethernet adapter that's in a given server, and it's a PCI card. It looks like every other 10 gig Ethernet card. But there's a special ASIC, a special chip embedded on that we can control from UCS Manager, from our management tool. And we can essentially tell that adapter to take on a new identity or identities. So what you see physically on the left there is a server, physical adapter, 10 gig Ethernet port running up to the switch, terminating on an Ethernet port on the switch. That's the physical pieces. But what you have inside of that server and adapter is the ability on the adapter itself through UCS Manager to create as many as many virtual adapters, whether Ethernet or fiber channel or both, that you might need for a given application. So you can create 3 Ethernet NICs and 5 fiber channel HBAs, or any combination there. There's a very large upper limit on it, hundreds of devices. And once you've done that, those devices, those adapters, are presented to the BIOS and therefore to the operating system as real physical devices. The operating system has no idea that we're doing any sort of virtualization of the network behind those devices. And so what you end up with on the far right there is a server that sees physical adapters as if they're real, and all the traffic is virtualized over a single pipe. So those are two generic, if you will, capabilities of UCS, the service profiles in the unified fabric. And now we're going to apply those technologies into the big data space. And so what we did as a company going back a little over 3 years is we took a look at the big data space and realized that this was taking off, and that it was going to be something that most of our customers were going to incorporate as a technology in the coming years. And so we kind of cut up or divided up the application market just from a conceptual level into 3 main groups, just to make it easier to target with our offerings. So you see here the kind of division here that we were looking at, and essentially we had Hadoop in the middle, kind of the poster child there for big data. And at its core, it is still primarily used as a heavy lifting sort of batch processing freight train type of solution. Obviously, that's changing daily. And in fact, I just came back from the Hadoop Summit out in San Jose, and they barely talked about batch or MapReduce. It was all about enabling SQL access and real-time processing and so forth. So the platform is clearly evolving, but the roots trace back to that batch processing world. As opposed to on the left, the NoSQL world, where you have numerous options here for key value type of processing, typically smaller block, stream processing, things like Cassandra or HBase or RIAC or Mongo, all manner of different offerings there targeting different use cases. And then on the far right, the massively parallel processing world. Here you'll see entries like Greenplum database or Par Excel, which I guess is now Actian. But all 3 of these categories have a common underlying principle or architectural foundation, and that is they're all essentially designed to run on a scale-out x86-based rack mount clustered architecture with fabric connecting all the nodes, a fair bit of east-west traffic, as we say in the network world, server-to-server traffic within the cluster, and usually expecting to see local storage within each node in a sort of shared nothing architecture and design. And so we went out in each of these 3 categories and partnered with leaders in these spaces to develop a common architecture, what we call our common platform architecture for big data, to support these different use cases and categories. And we've developed, as a result, this CPA, this common platform architecture based on the Cisco Unified Computing System that I started the presentation with. And under the sheets, what it looks like is a standard rack 2RU rack mount server, the C240 M3. That's a 2-socket Intel x86 server with the capability to go between 12 and 24 internal disks, depending on your configuration. Moving up through Nexus fabric extenders for the top of rack switching connectivity, and terminating at the Cisco Fabric Interconnect, the 6200 Fabric Interconnect, which is where all of that switching and management takes place. That's where the UCS Manager database sits. That's where we store those XML files. That's where you log in to manage the overall clustered computing environment. And as I mentioned, we've partnered with each of those vendors I showed on the previous slide and developed what we call Cisco validated designs. And I'm sorry, I'm having a little trouble advancing to the next slide. I'm wondering if somebody could
I got
take
it for
over.
you. Yep, go
Thank
ahead.
you. I appreciate it. I apologize. I'm just getting a little beach ball here on my end.
No, you're ready. Go ahead.
Great. So what we've done with those vendors, those partners that I showed on the previous slide, is create a Cisco validated design, CVD, and you can see some of them listed there at the bottom of the slide with major distributions. And what these are reference documents, 100-plus page detailed documents that show how to build a given architecture with UCS, Red Hat as the Linux distribution, and then, for example, Hortonworks or Cloudera or MapR as a software Hadoop distribution, and detailed screenshots, step-by-step configurations on how to do all that. The URL is, I think, there in the slide, cisco.com/go/bigdata. Can you advance to slide 22, please?
Yep, go ahead.
And as I mentioned, with that overall architecture, the Common Platform Architecture, CPA, we've built numerous individual bundles effectively, taking those components and applying them to essentially not so much a starter kit exactly, but a different level of configuration underneath that overall reference architecture to give some consumer choice for a given application. So you might pick the performance configuration for a heavy-duty, massively parallel processing relational database, whereas you might shift over to the capacity version of the application, of the architecture for a more pure play Hadoop implementation, and then maybe the capacity performance combined option for something like HBase. So lots of choice there, and the point is not to necessarily have a rigid, structured appliance-like delivery, but to have some good options to begin with, and then if you need to customize within any of these configurations, it's certainly possible to do that, no problem. Slide 23, please. And so what we have as far as a scalable design and approach in these with this common platform architecture is beginning with a single rack, and this is a build slide. So on the first part of it, we have that single rack, and in that rack are 16 of those 2RU servers with fabric extenders, the top of rack switching component, and the fabric interconnects, which is that central database, central switching location. And if you step through the next part of the build, what you'll see is when we add racks, you'll have additional racks that come in with just the 16 servers and the fabric extenders. Those are inexpensive top-of-rack switching devices, but those fabric extenders plug into the central fabric interconnects. And we can scale that model out to 160 servers under a single pair of fabric interconnects, giving capacities up to, I believe, somewhere in the neighborhood of 7 petabytes of storage in that one domain, what we call a domain. Beyond that, and if you do the last part of the build here, you'll see when we do grow beyond that 160 server domain, we have a number of customers that are in this range. This is starting to get to the real big data type of deployment. It's simply a matter of connecting those multiple domains together with another layer of switching as a spine. And I'm showing a cloud here intentionally because there are a number of different switching options within the Cisco data center portfolio to act as a spine and to provide that sort of interconnect capability. And there's lots of good choices there. I'd be happy to talk to anybody about what might be best for your implementation. Moving on to slide 24, please. With the overall architecture and with this clustered computing capability in the common architecture, what we see then is the ability and what we've intended our customers to be able to take advantage of, is the ability to manage their cluster consistently throughout its life cycle. And so this is not just at provisioning time. It's certainly at provisioning time, but not just at provisioning time. When you roll in the first rack or two of servers, you want to build those up and make sure all the data nodes, let's say in a Hadoop example, let's use that. You want to make sure all those data nodes are built consistently. They all have the same settings, or from both the network, the BIOS, the firmware settings, all of those pieces together. And ensure that they are done consistently, not just at the provisioning time, but also when we grow the cluster and extend it, when we monitor and maintain the cluster. So when it's time to essentially, for example, do a firmware update across all the nodes in the cluster, whether you're at 16 or 32 or 160 or 500, you want to do that in a consistent fashion and ensure that we are bringing all the nodes up together. And the reason for that, essentially, and I'll give you a quick example. And this is actually a customer that came to us having run into this problem on a different vendor solution. They had one node, I believe it was like a 100-node cluster, somewhere in that range. They had one node in their Hadoop cluster come up half duplex on the network due to a misconfiguration. Somebody fat-fingered config. And that under most, kind of data, they had a critical job that was a time-critical job that ran a couple of times a day. And usually when that job ran, it went okay. Things worked okay. But every once in a while, that job would slow down to the point of taking 4 or 5 times as long to complete. And they couldn't track this down. And when they get the complaint, the cluster admin would log in and see it was going slow and kill the job and restart the job. And then it would run fine. And it would run fine for another 20, 30, 40 times, and then it would slow down again. And what effectively was happening, this is an oversimplified example, but effectively what was happening was that when it was running fine, the slow node, the half duplex node, was only running map processes for the job. And so it was sending its output to the reducer over a slow link, but it was only one of 100 servers doing that. When it was running poorly, it was the reducer. So it was receiving from 100 servers their outputs during the sort and shuffle phase, receiving their outputs over a tin can and string, effectively as a connectivity capability. So it was under those circumstances that it would slow down, but it was very intermittent because statistically that server didn't show up as a reducer for that job very often, right? Given the size of the cluster. And it's that kind of sort of chase your tail scenario that customers will run into, especially as the clusters start to scale. It's easy enough to maintain consistency at 8 nodes or 9 nodes or maybe even 12. But when you get into the many tens of servers, certainly into the hundreds of servers range, that becomes less straightforward. And so having those service profile templates essentially eliminates any kind of inconsistency, whether it's at initial provision, any kind of maintenance of the cluster, or during its growth cycle when you add new servers 9 months later. Right? How do you make the new ones look like the old ones? Next slide, please. Again, this is a build slide. And this is going to show some of the network capability that I mentioned earlier with the unified fabric. And in this example, I'm showing the ability to have 3 separate network interfaces on every data node without paying for 3 separate interfaces on every data node. So these are not physical ports that you have to cable and provision and maintain. These are virtual interfaces that you configure through UCS Manager that all leverage that same unified fabric. And in this example, we'll have a VNIC 0, which is we'll assign to its own VLAN and use as our management VNIC. And if you advance the slide to the next build, you'll see the VNIC 1 traffic, and that will be our HDFS VLAN. effectively. That'll be our internal Hadoop VLAN. And so every server is going to have a VNIC on that, of course, and that's for all of our cluster traffic, internal cluster traffic, east-west traffic. And then advance once more, and you'll see VNIC 2 being our ingress-egress VLAN. And that allows data to come into or out of the cluster through northbound access from elsewhere within the network. So, maybe data flowing in through an ETL process or data flowing out, dumping into a relational database maybe. And the point here is that rather than having to build separate infrastructure for a proxy, for a gateway, because typically you don't want to expose your internal Hadoop network, rather than having to add servers whose only purpose in life is basically to bridge the Hadoop cluster to the rest of the world and sit on both networks, there's no need for that. We can simply spin up extra NICs, however many you need, on one or more or all of your Hadoop nodes themselves. Furthermore, let's say I'm showing VNICs here. Let's say instead of VNIC 2, you have HBA 2 or HBA 1. Meaning you can have your data nodes sitting directly on your SAN, fiber channel attached effectively, so that if you are using Hadoop as a ETL engine and you want to dump the output of a ETL job, a Hadoop job, directly into your SAN rather than, again, having to orchestrate some sort of gateway approach. You have that ability. It's built in. You're not paying for extra cabling. You're not paying for extra ports. You're not paying for the separate SAN for every server or anything like that. It's all built right in. And then lastly, if you can advance the next slide, I'll show you an example of how this unified fabric and this dual network capability or multiple network capability, I should say, might apply to a mixed workload. Again, using Hadoop as the example here. And what you're seeing is a test that we ran with a single Hadoop cluster running two very different workloads. One, MapReduce TerraSort, so very heavy-duty batch job, and low latency HBase reads coming from a YCSB Yahoo Cloud Serving Benchmark workload on separate networks. And so we kicked off a test, a baseline, and we run the HBase read load, and you can see the latency on the left there. It's fairly low and flat, and so we're getting our reads, no problem. And then we fire off a TerraSort job, and we see this massive spike in read latency for the HBase clients because they're competing for resources with TerraSort. Now we rerun that exact same test. The second time, however, we turn on quality of service because we can do that within UCS very easily. It's a click of a button. And we prioritize the HBase traffic, and we deprioritize the TerraSort traffic. You don't have to do that. You can choose your priorities, but that's the test. That's the example. We rerun the test, and when the TerraSort job kicks off, you can see a much more muted spike, a 60% drop, or improvement rather, in the penalty paid when running those mixed workloads. The bottom half of the screen is on the second run. It's a graph of the buffer utilization on the switch, and essentially TerraSort is being buffered. That traffic is being buffered by the quality of service mechanism, and the HBase traffic is the flat red line at the bottom being passed right on through. And so if you can advance the last slide, please. Essentially what we're providing then with this platform for big data is the right form factor for the right application. And if some of you may be aware that UCS also comes in a blade form factor, and that's where we actually began in the computing market about 5 years ago. We just hit number one in the Americas, by the way, number one blade server vendor in the Americas, and did that in 5 years. That blade application is great for traditional enterprise applications like Oracle or SAP or SQL Server, what have you. So that's a blade and SAN combo, as you see on the right. And we can extend that now with our common platform architecture for big data using rack mount servers, which are better suited for that architecture. We can actually commingle these under the same UCS domain manage them exactly the same way, whether blade or rack mount. Same tool, it's just a different tab for blades versus rack mount. Same profiles, same resource pools, everything, all that management is the same. And the whole idea here is to make it easy to transition into a big data implementation using a common management framework of UCS and using the right form factor for the right application. So with that, I will hand it over to our friends at StackIQ to let them show how they've leveraged this UCS capability into their tool as well.
Thanks, Shawn. I appreciate it. This is Tim from StackIQ. I'm going to walk through a little bit of history on the company and then go through the StackIQ platform. At a high level, much of what you'll see from StackIQ is the same sort of abstraction for complex software that Shawn spoke about UCS providing for complex hardware configuration. So the company is all about intelligent infrastructure automation for clusters. We have an over 10-year history in the high-performance computing space. Our founders developed the open source ROCs cluster distribution. And what we saw in that space over the years is to manage commodity infrastructure at scale for a complex clustered application. You need to manage systems from bare metal, and you need to go all the way up to a running application in a single step. And it was interesting to watch as the hyperscale companies evolved over that same period of time. If you look to the Amazons, Googles, Yahoos, Facebooks, they took a similar approach to how they manage systems. It's starting to be referred to as web scale IT in today's parlance. So StackIQ, in many ways, is bringing web scale IT to traditional enterprise customers. Some of the benefits, the simple value proposition is that StackIQ automates the provisioning and management of big data, OpenStack, and HPC clusters from bare metal through the applications layer. And some of the key components provided as part of the stack. Management, we provide a holistic management solution versus a siloed solution. I'll describe that on the next slide. Complete automation of the entire stack, intelligent dynamic automation rather than using a set of homegrown scripts, checklists, spreadsheets to manage complex data center infrastructure. Complete personalization. So despite offering a holistic solution, we give you the ability to define clusters that meet your site-specific needs. The solution's completely modular. We're agnostic, for instance, to what Hadoop distribution you choose. We have very close relationships with Hortonworks, Cloudera, and MapR, and joint customers with all of them. We've also worked with some of the other Hadoop distributions. And then agility, flexible versus proprietary. So rather than locking you in to a management solution or a stack from a single vendor, or tying management tools to a given application, tying management tools to a given hardware solution, StackIQ allows you to integrate in with the hardware and software of your choice. So moving to the next slide here, we'll go through a quick architecture comparison. On the left-hand side, and this is going a little slow for me, here we go. On the left-hand side, and I'll build out to the right side, is what we see in every account that we walk into prior to a StackIQ implementation, where you have siloed services, siloed teams, and siloed software for managing each layer of the stack. At the bottom of the stack, you typically have one solution for bare metal provisioning, satellite server, Tivoli provisioning manager, cobbler, system imager. Those images are usually built by hand or developed and pushed out with static kickstart files. On top of that, you have manual server config, manual networking, disk configuration that has to happen before you start laying down site-specific tools. At the middleware layer, scripts and checklists, sometimes abstracted by a DevOps solution like Puppet or Chef. We work closely with the DevOps community, but we do more. Rather than just automating the middle layer of the stack or individual services, we're taking that same philosophy and extending it both above and below the middleware layer. And then at the top of the stack, management tools that are specific to a given application. So whether they're Hadoop management tools, OpenStack scripts, a solution like Red Hat Foreman, which we integrate with, but as a standalone is difficult to deploy and manage. And then that process repeats itself over time. As you bring in new servers, you have to develop new server images. You have to do manual disk and network configuration again, altered scripts and checklists to match your underlying infrastructure. And then every time an application is added, that's a new separate configuration process. So with StackIQ, that process is collapsed into a single solution where you can go all the way from bare metal through site-specific configuration to a running application in a single step. I'm trying to get back to this slide here. I have a little bit of lag. All right, let's just move forward to platform. So platform, I'm going to walk through the items in gray, which are the items that StackIQ manages, and the items in blue on the left-hand side are what StackIQ does. First difference you'll note versus other solutions, as I described before, is scope. Starting with heterogeneous hardware discovery, StackIQ will discover what hardware is available and automatically match software configuration to the given hardware. And we'll talk about some specific integration we have with Cisco UCS in the next couple slides that gives us some great advantages. Controller configuration, with just about every other solution, you're doing disk controller configuration, hardware RAID configuration after first boot or as a manual process. With StackIQ, we're abstracting the configuration of the controller before we lay down the OS. So we'll look at what appliance a given server should be, and we'll look at what disks are available, what controller is available, automatically set a proper RAID array. For instance, on a Hadoop data node, we may set 22 disks up as a JBOD and 2 disks mirrored as a RAID 1 for the OS. For a cluster running Cassandra or Gluster, we might set it up as a RAID 6. And this can be heterogeneous as well. We're counting how many disks are available. We're looking what application is assigned to each appliance type and assigning those controller configs on the fly. Through the operating system provisioning, we support Red Hat and Red Hat-like versions of Linux. So that's Red Hat, CentOS, Scientific Linux, Oracle Linux. We can also manage multiple distributions within a single cluster. So whether that's running Red Hat Enterprise Linux on management nodes and CentOS on backend nodes, or whether that's running multiple distributions for dev, test, and prod, changing the distribution of a given appliance is a single command in the StackIQ framework. And with the operating system config above the OS layer, another disk configuration step, setting mount points, parallel formatting of disks, and most importantly, handing that information off to the applications layer. So in the Hadoop example, for instance, your HDFS core.xml file for each different type of node on your cluster needs proper mount point set for each disk that's available to it. In the case of a disk failure, that HDFS core XML file is going to change. StackIQ will do that automatically. Network configuration, we're talking about host-based network configuration. So once Cisco does its goodness with the hardware switch configuration and setting up VLANs, StackIQ does host-based network config. By default, that's a single network for both management and application traffic, but with our experience in the high-performance computing space, we've become particularly good at managing systems that have multiple networks, whether that's a separate high-speed interconnect like InfiniBand, MirrorNet, or a 10 gig E network for applications traffic, whether that's bonding to 10 gig E networks for higher throughput. Each of those actions can be done through the StackIQ framework at scale with a single command. And then up at the top of the stack in the gray and moving to the blue, package configuration and service management. Complex cluster applications depend on what type of infrastructure and how that infrastructure is configured beneath the applications layer. So instead of going through 40 pages of prerequisites before you can start with a Hadoop management tool, or going through 100 pages of docs to get an OpenStack cluster up and running, or to go through a site-specific process to get an enterprise Linux application up, StackIQ integrates that process into the StackIQ framework, and the tight integration between the applications layer and the infrastructure layer allows you to set rational defaults and known good configuration on first boot. And then last, system visualization, diagnostics, and repair. No matter how well your cluster or data center is designed, it will change. You'll have bottlenecks. You'll have failures. You'll need to update software on the cluster. You'll need to replace or repair nodes in the cluster. So StackIQ provides a rich set of tools for monitoring infrastructure components and then for enacting change on your cluster. So going to the next slide, we'll talk about Cisco UCS integration and one customer success story, and then open things up for questions. We're really excited about the partnership between StackIQ and Cisco and the great work Trace3 has done to integrate the solutions together for their customers. We found the handoff between UCS and StackIQ to be a perfect fit. You'll note on the top of this diagram describing the functionality that UCS provides, third-party enterprise management systems. That's exactly where StackIQ fits in. We have integrated with the Cisco UCS Open XML API to pull information on Cisco UCS service profiles. So rather than with other hardware vendors where we have to rely purely on Pixie and Anaconda for system discovery, we can grab information from UCS Manager on new service profiles that pop up on the network, and also use a field that's available inside of the OpenXML API to even define appliance types. So for instance, you could live inside of UCS Manager, use that open field to define that a certain node should be a data node, that another node should be an admin node, that a node should be running Zookeeper or Hive or HBase. And as soon as that system hits the network, StackIQ will do all of the software configuration required, from bare metal through middleware configuration up to configuring that Hadoop service in a single step with no interaction from the end user. And I'll touch on one customer success story that both the teams from Cisco and StackIQ are particularly excited about. This is a large credit card vendor who's running a combination of StackIQ and UCS. It's heterogeneous clusters. When we came into the account, they looked like the left-hand side of that diagram on the architecture comparison, at a mix of homegrown tools, Red Hat Satellite Server, Puppet. They had about 150 nodes, and as they plan an expansion to an additional 500 nodes, and then we're looking out to a following year expansion to over 1,000 nodes, which is about where we sit now. They thought about what it would take to scale that system, and whether or not that left-hand side, that combination of multiple tools, multiple departments, and homegrown work could scale to meet their needs, and that they found that meeting the timelines of their business users was simply not possible. They turned to StackIQ. They chose Cisco UCS for the build-out, and we were able to provision and get that system up and running an additional 500 nodes in a matter of a couple days, and then hand the system off to their production users a couple days later with their site-specific configuration. They continue to leverage a combination of StackIQ and UCS to manage multiple clusters over multiple domains and multiple physical data centers every time they do an expansion. And you can see a great video of this online that Cisco put together. It's simply a matter of racking and stacking the UCS servers. They're discovered by Cisco UCS Manager, automatically connect to the StackIQ Cluster Manager, and with a matter of an hour, they can have a new rack of servers online and hand it off to their production users. So with that, I'll stop and thank everybody for their time, and thank Trace3 and Cisco for inviting us to participate in this, and we'll open up to questions.
Great. Thank you very much. That was a great presentation, guys. We're going to move on to the Q&A portion. For our audience out there, the slide that you currently see provides the contact information for Nick, Tim, and Shawn. You can take that down if you have questions following today's webinar. Thanks to the audience for asking some great questions, which I'm going to go into now. And feel free to continue to ask along the way. We have about a little less than 10 minutes to go. So the first question is, where do you see the biggest challenges for organizations that are planning to scale out a current or deploy a new Hadoop environment? Can you guys hear me okay?
I'm sorry, can you read that again?
Yeah, I'll let you guys decide how you want to answer that question, but it's essentially, I think this might be one for Go ahead. Whoever thinks they can answer the question. Did you guys hear the question okay?
Yeah, do you want to repeat the question once more?
Okay, I'm going to ask it again. Sorry about that. Where do you see the biggest challenges for organizations that are planning to scale out a current or deploy a new Hadoop environment?
This is Shawn Francisco. I'll start with that. And as I touched on, I think a little bit earlier, the biggest problem that we typically see is that there's a level of visibility that's lacking between the software and the hardware. The cluster management tools for Hadoop are quite good and getting better all the time, but they essentially stop at the operating system layer and don't continue the visibility down to the physical bare metal and network. And that's where I think ECS really shores up the difficulties that customers are facing there and provides that ability to connect between the two. And that's essentially what StackIQ has done by leveraging the open XML API that ECS uses for its bare metal configuration, as well as tapping into the Hadoop software itself. StackIQ can extend that visibility to both software and hardware and maintain that as you scale. As I said earlier, building a 5-node cluster is easy enough to get right and consistent. Maintaining that as you go to 50 and then 500 is a different ballgame.
Yeah, I think Shawn's right on, and a lot of the challenge as well is just having management tools that are ill-suited for the given problem. You know, the traditional data center management tools that have been in the enterprise over the past 10 years, you know, were not designed for clustered applications. So when you move to a system that is specifically designed to manage cluster infrastructure at scale, that was designed to solve the problems that you see for not only managing the cluster services, but for managing all the complex OS, hardware, disk, network configuration that goes below cluster services. You know, that's really the key. Most enterprise customers are building clusters for the very first time, and it's simply a different problem. Clusters are different than general enterprise applications.
Okay, very good. The next question, this one's for Nick at StackIQ. Where have you, can you provide some, I guess, additional examples of where you've deployed Cisco and StackIQ? I'm sorry, this is for Nick Trace3, I beg your pardon.
Yeah, sure. So getting back to even our agnostic approach, right, we worked with, specifically on our reference slides was Honda, right, and we actually did Big Insights. So not even one of your traditional, IBM's Big Insights, not even one of your traditional Hadoop deployments, but for them to be able to scale and to be able to build truly enterprise scale, they needed a way to actually automate this and make this repeatable and make this something that could be, you know, as they grow and as they move forward, that could function. Beyond that, you know, you look at Verizon, we started with a small POC with like 30 nodes that they were having trouble getting up on a Cloud Air distribution. And within a year now, they've got over 1,000 licenses of StackIQ on some UCS and on different hardware. But altogether, you know, this provides a solution that gives you all the capabilities to be able to manage and actually operate. And we do that amongst a lot. We're working through with certain other large vendors, Qualcomm looking at doing the same. But there's some pieces and parts that we want to actually, you know, be able to manage and give that full layer to these systems teams, to the teams to be able to really operationalize that piece. Okay,
very good. Next question is, you mentioned bare metal provisioning. How is StackIQ different than other bare metal provisioning tools like DMC or Blade Logic?
Two key items. One, we manage clustered services as well, as opposed to just stopping at kind of the lowest common denominator configured system with an OS that has a ping and a prompt. But probably more importantly is our ability to dynamically generate system configuration. So we never deal with a pre-baked system profile, a pre-baked kickstart image, a pre-baked image. We're on the fly generating kickstart to match heterogeneous hardware to the given application type. We also are significantly better at scale. StackIQ includes the Avalanche installer that we developed as part of our open source efforts, which does parallel peer-to-peer package sharing both for initial provisioning and for change management. So for a clustered application, we give you that ability to truly treat bare metal as disposable, whereas that's not the paradigm for a traditional systems management tool.
Okay, very good. Do I have to choose the exact config in your bundles, or can I order a custom config based on what my needs might be?
The answer to that is the latter. Those bundles that I showed earlier are essentially starting points. They're kind of the 80-20 rule. They cover probably 80% of the typical customer use cases and needs out there. One of those four will cover the vast majority of use cases. However, they are absolutely configurable. They are not a rigid appliance. If you find the need for, say, a different CPU or more or less memory or a different disk configuration, we will absolutely support that. No problem.
Okay, very good. One of our attendees was planning on building up Hadoop at Amazon EC2, and I guess one thing he could not get to automate himself was the keywordless SSH. How do you deal with that if there are 1,000 nodes to communicate with each other?
So you'll have the same problem there whether you're provisioning a cluster inside of EC2 or on physical hardware, and that's another component that's managed through the StackIQ framework. So we'll automatically set up passwordless SSH between backend nodes. We'll automatically generate keys. Part of the provisioning of the StackIQ cluster manager sets up a unique root key for the system. That's another example of cluster config that you have to do before you set up any clustered application, whether it's Hadoop or Cassandra or OpenStack, that has to be handled properly before you get to the applications layer.
Okay. One more question is, how quickly can StackIQ get Hadoop system up and running from bare metal?
For both the StackIQ cluster manager and backend nodes, starting from bare metal, whether it's 10 nodes, 100 nodes, or 500 nodes, it's about an hour. And 30 to 40 minutes of that is setting up the StackIQ cluster manager. Backend node provisioning in parallel runs in about 10 to 15 minutes.
That's incredible. Okay, we have time for one more question here. I'm going to let this be the last one. Can I virtualize on this platform?
This is Shawn again. I'll take that. Yeah, absolutely. Hadoop doesn't know exactly, right? Hadoop sees an operating system and doesn't know whether it's a VM or not. And UCS absolutely supports virtualization. In fact, UCS was in many ways built for virtualization when it came out 5 years ago and continues to lead in that area. That said, I would ask the question of are you sure you want to virtualize? And that really has nothing to do with UCS or StackIQ or anything else, but more to do with Hadoop at scale. At a lower scale, virtualized Hadoop will be fine, and it's a good choice for proofs of concept rather, or other test dev types of needs. When you get beyond that into a production deployment at a reasonable scale, I think you'll find typically that the hypervisor introduces overhead that isn't really helpful. Even if the overhead is small, you have a level of complexity that doesn't really add much to the overall deployment, assuming, again, it's a production, more static type of deployment, not something where you're building and tearing down on a regular basis. But yes, absolutely, happy to support that, and it can be a good choice depending on your use case.
And same answer from a StackIQ standpoint. We treat virtual machines the same way we treat physical machines, but Shawn brings up some great points about performance and scale.
Okay, great. That, as I said, has to be our last question for today. Again, our audience, please take down their information if you do have questions later on. And rest assured, any questions that were not answered today, all of them will be sent to Nick, Tim, and Shawn, and they can follow up with you directly. So thanks for some great answers, guys. I just have a couple of quick announcements to make. Please mark your calendars for June 24th and our next Data Science Central webinar, Facing Dangers Known and Unknown with Big Data Analytics, which is sponsored by Platfora. Also, as I mentioned, this event is being taped and will be made available later on this afternoon at Data Science Central. This brings today's webinar to a close. I'd like to thank our audience for their attendance and great questions, and a special thank you to Trace3 for their sponsorship, and to Nick, Shawn, and Tim for their insight into today's topic. My name is Tim Madison. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on June 24th. Good day.